Reduction and elimination of chromates in maintenance operations has long been a goal of the Air Force. In the U.S. Air Force, the primary means to protect exterior aircraft surfaces is through a combination of chromate conversion coatings, epoxy primer, and polyurethane topcoats. Chromate conversion coatings, commonly referred to as Alodine, prepare the aluminum surface of the aircraft for the application of primer and paint and provide a corrosion-resistant barrier. The primer ensures adequate topcoat adhesion and also contains chromates that provide additional corrosion protection.
For the past year, OCALC has been proactively taking the initiative in evaluating alternatives to reduce hexavalent chromium. One alternative considered is a non-chromium surface preparation process called PreKote. Through initial analysis, PreKote is expected to provide threefold benefits. 1. Better aircraft protection. Enhanced adhesion of the primer coating, resulting in better corrosion protection. 2. Production savings. Potential reduction in time and cost due to less materials utilized and simpler processing steps in depot. Potential decrease in touch-up work required in the field due to better adhesion. Finally, environmental savings. Reduction of water usage and treatment cost, reduction in disposal costs due to the elimination of chromium, and the elimination of toxic release inventory reporting of chromium associated with aircraft's pre-treatment process. We have applied PreKote onto each of our weapon systems, KC-135, B-52, E-3, and B-1B. As more aircraft are added to the list of PreKote prototypes, it allows more analysis to be done to further justify the three benefits mentioned previously. Today, we will apply PreKote on a scuff stand B-1B and compare that with the normal standard Alodine process.
Well, we're looking at PreKote to apply to our wing leading edges. We've had problems with paint adhesion in those areas. Some of our deployed aircraft out in the desert, after 2 or 3 flights, have seen degradation of the coating on the leading edges. So we're going to apply a PreKote application to this aircraft after it's been scuff sanded. After it's scuff sanded, you have your dust from your paint that's been sanded off. Also, oxide has built up on that coating. So the PreKote will remove all that. It will remove any residue of hydraulic fluid and fuel so that we get a good bonding surface, and it will prep the pores of the aluminum substrate at a molecular level by filling in those voids, giving more surface area for the primer and top coat to adhere. So it should give better paint adhesion. So those are 3 aspects that we're looking at for the PreKote application to give us better paint adhesion for the coating that we're going to apply. B1s have been around since 1985, and we've had 3 or 4 layers of coatings applied. Some of those lower layers of coatings are becoming disbonded and are not adhering as well as a new layer of coat. So we're hoping that after we scuff sand, get all the bad coating off there and apply the PreKote, that we're going to get a good bond of the new coat that we put on there. The Alodine that we apply right before we paint has chromates in there, so we're looking at a reduction in chromates. PreKote has no chromates in it, so the chromate that is in the primer will provide adequate corrosion protection, and while eliminating some of the waste stream problems that we have with Alodine. So we're looking at that also. Also, the B1's had problems with leaking hydraulic fluid and fuels like that. PreKote does an adequate job of cleaning those fluids off, giving a good surface bond, and hopefully the top coat and primer that we apply is going to have good adhesion.
Approximately 85 aircraft come through Tinker annually for a paint job. Using the PreKote process that has been prototyped at Tinker will reduce the amount of water required, equating to a theoretical annual savings of $113,000 in water purchasing, treatment, and disposal costs.
The standard aircraft coating procedures are: first, we alkaline wash and rinse the aircraft. Next, we skin brighten or acid etch the surface of the aircraft, followed by a rinse. Then we Alodine the aircraft and rinse. Once the aircraft has been allowed to dry, this is followed by primer and top coat application. In the pre-coat process, we have one material replacing three materials. The process that we have been evaluating involves first rinsing the aircraft, then applying the pre-coat material, post-scrubbing the pre-coat material, then we reapply the pre-coat material, post-scrub the aircraft again, then we rinse off the material. We let the aircraft dry, and once it's dried, we apply the primer and top coat.
The employees are in favor of the pre-coat process because it gets away from the chromic acid and the sulfuric acid that we used to have to use. They also like the fact that they only have to apply the pre-coat in two areas. It saves them rinsing and application time. We've cut the time down on processing to approximately an hour and a half. Ideally, we'll get down to between 1 hour and 1.5 hours versus the old 2.5 hour process, which will save us a lot of time in the PDM. It also cures faster because we don't have to go back and re-rinse after the Alodine process, which helps us to cut down dwell time and time for the aircraft surface to dry to get ready for primer. Using the non-chromated pre-treatment system, or the PreKote, we've changed the traditional way that we've started the process. What we're doing on this aircraft is starting on the upper surfaces, working our way down and out, and then working the lower surfaces last. This prevents the PreKote from drying on the surface of the aircraft or causing us to have to go back and reapply PreKote to areas that we previously worked. We work smaller areas, but when we're finished with the area, we don't have to go back. With the old process, we had to go back over the area 3 different times with 3 different chemicals that caused us more time. The PreKote process has saved us approximately 1 hour in production time because we don't have to use 3 chemicals.
Basically, we have to pay special attention to underneath the nacelle area and the underneath of the fuselage. We have a lot of hydraulic and fluid leaks of fuel on the B1. Those basically are contained on the bottom surfaces of the fuselage and the nacelle. So we have to pay special attention, make sure that we properly apply the PreKote, adequately scrub and clean so that all those materials are removed. After the PreKote process is performed and the surfaces have dried, ready for primer and top coat, we may have to go back with a wet rag with PreKote, wipe those areas off, allow them to dry, and then apply the primer. Because we're going to make sure that all those hydraulic and fuels are removed before we do primer and paint. Right now we have the Corrosion Technology Integration Officer, Wright Pat, helping us monitor some of our aircraft that we applied PreKote to. Back in 2003, we also applied advanced performance coatings to 2 aircraft, and they're helping us monitor those. The advanced performance coating, we're hoping to get 5+ years life of the coating without it coming back all chalky and fading. Better paint adhesion, weather resistance. So we're looking at that from the aspect of hopefully when the aircraft comes back in 5 years to PDM that we may have to do minimal paint touch-up maintenance to it. Also, they're helping us monitor the PreKote aircraft, and we're hoping that those aircraft, the paint will adhere better. So in a combination with the PreKote and advanced performance coatings, we're hoping to potentially get 10-year service life. So every 5 years when the aircraft comes back after it's been pre-coated and advanced performance coatings applied, potentially we won't have to do any paint work on our second PDM cycle. So that's one thing that we're looking at. Could be a huge impact to the B1 as far as cost savings.
Chromium has been identified as a hazardous material of concern and is targeted for elimination or reduction. Joint efforts between the system program offices at Tinker Air Force Base, Environmental Management, Aircraft Production Engineering, Headquarters AFMC LG, and AFRL, and PreKote manufacturer Pantheon Chemical are continuously working together to assess the performance of the pre-coated aircraft in order to make a decision on when acceptable performance levels in terms of adhesion and corrosion are achieved.